Hello, today we're going to explore valency, which continues on the composition of atoms we covered yesterday. What is valency? It is a fundamental concept in chemistry which describes the combining capacity of an atom, and it is determined by the number of valence electrons in the valence shell, which is the outermost shell. It is because it is only these electrons that an atom can lose, gain, or share, because its goal is to complete its octet, it, which is, or in the case of hydrogen, is a duet, but the rest is all octet. So if you recall the periodic table, I had this in red, the valence electrons, 1 for alkali metals, 2 for alkali earth metals, 3, 4, 5, 6, 7 for halogens, and 8 for noble gases. So if you recall, we had the number of protons being counted in the center, which always equals the number of electrons. So we're going to now skip it and just in the nucleus indicate the atomic symbol, and the valence shell is visible. So right now you can see that there is one electron, so the valency is 1. Helium has a second electron, so it has reached its octet rule. It is in steady state, therefore I have grayed it out, so it's no longer available. These electrons are no longer available for giving, sharing, etc. So it is now inert or in steady state. When lithium comes along, there is a third electron. So now it opens up the new shell, L. This is now the valence shell. And therefore in the valence shell there is only one electron, so the valency is 1. Beryllium adds a fourth electron, but actually there are only 2 in the valence shell because 2 have been already taken in the inner shell. So first shell. So we have valency is 2. Boron introduces a third electron, so there's 3 in the valence shell, so the valency is 3. Carbon introduces a fourth, and therefore its valency is 4. Nitrogen introduces a fifth bit, attaches to the first, as you can see. So, but there are 5 in the valence shell, so the valency is 5. Oxygen brings in a sixth electron, which attaches to the second one in the valence shell, but you see 6 overall, so the valency is 6. Fluorine brings in a 7th, so though its atomic weight is 9, and there are 7 electrons in the valence shell, valency is 7. And when the 8th electron attaches, the octet is complete. We now have neon, but it is grayed out because it has now reached steady state, it has gone inert. So the third shell opens up to accommodate the new electron from sodium. So shell M is now the valence shell, and because there is only one electron in this valence shell, its valency is 1. Magnesium, second electron, but only 2 in the valence shell, so the valency is 2. Aluminum introduces a third electron, valency 3. Silicon introduces a fourth, therefore valency is 4. Phosphorus introduces a fifth, valency 5. Sulfur introduces sixth, valency 6. Chlorine introduces a seventh, valency 7. And argon introduces the 8th, octet is complete, it has gone inert. So when potassium introduces a new electron, the new valence shell opens up, shell N. So shell N is now the valence shell. The others are now inert. They will not give or take any electrons. Only this guy is in play. And therefore, and calcium has 2, so the valency is 2. And that's so on and so on. So now I have superimposed these on the periodic table. And once I remove those labels, you can see that in shell K you had 2. So you got hydrogen with 1 valence electron. But when you come to lithium, it also has 1, And in the shell M, you have sodium, also has one, and in the shell N, you have potassium. So you observe that alkali metals all have one valence electron. So their behavior will be the same. There's only one difference. The smaller the valence shell, the more reactive it is. The bigger the valence shell, the less energy and therefore the less reactive. We'll come to that. So now in the second column, we have alkali earth metals. Observe, 2 electrons, 2 electrons, 2 electrons, all of them in the valence shell. Same for 3, 4, 5. Observe they're the same here. 6, 7, and inert, which is like so. So this lays the foundation for us to now start discussing covalent and ionic bonds.